All right, welcome to our last unit. Woohoo! So looking at section 9.1, we're going to start to look at sequences. And sequence is a function. All right. Now here's the key, whose domain is a set of positive integers. No negative numbers, no decimal numbers, no fractions, just integers. Okay, it can start at 0 or it can start at 1. If they don't tell you where we start for your input, and it's a 1. So the function values are a sub 1, a sub 2, a sub 3, a sub 4 to a sub n. So we're going to change our function notation to represent a sequence. So if the domain consists of the first n positive integers only, the sequence is a finite sequence. So we can go on forever or we can end. So to show you the difference between our normal function f of x and a sequence function, which is now a sub n, first of all, no parentheses. Your input is the subscript variable. A is the name of the function. Just like f was the name of the function, x was your input, you had to have x in your expression. Here, n is the input, n has to be in the expression somewhere. So if I look to find the first 5 terms of this sequence, a sub n equals 2n plus 5, we let n equals 1. They did not declare where n starts, so therefore it's presumed to be a 1 by definition. We put the 1 in. 2 times 1 is 2 plus 5, 7. Then we're going to do n equals 2. A sub 2 is equal to 2 times 2 plus 5, which is 9. N is 3. A sub 3 is 2 times 3 plus 5. 6 plus 5 is 11. A sub 4, 2 times 4 is 8 plus 5 is 13. N equals 5. A sub 5 is 2 times 5, which is 10, plus 5 is 15. Because this is a linear function, which looks just like this, we know that if my n's increase by 1, then your slope is going to show you the change in your y. So from 7 to 9 is an increase of 2. I increase by 2 to 11. Once you see the pattern, or once you find your starting number and you're working with a linear sequence function, then you'll be counting by whatever that slope is. So once you get 7, you could then go 9, 11, 13, 15. Boom, there's my sequence. Next, let's go ahead and the first 5 terms of this sequence. This one has something a little different. We have negative 1 raised to the n power. So, and we have a linear function on the bottom, so we're going to get the same effect as we had these numbers, but in the denominator. Let's talk about the numerator. If I'm going to be raising this to positive integers, I'm either going to have odd numbers or even numbers. So when my n is odd, I'll have a negative 1 in the numerator. When my n is even, I'll have a positive 1. So we're going to have alternating signs in the top. So to find a sub 1, n is 1, negative 1 to the 1 power, negative 1. 2 times 1 is 2 plus 1 is 3. That's my first term. So by guess, using prior knowledge here, alternating signs, the next one should be positive 1. And because it's linear, my slope is 2. My denominator is 3 plus 2, 5. So it's going to be positive 1/5, negative 1/7, positive 1/9, negative 1/11. So just to double check, there's your negative 1 squared. There's the positive 1. 2 times 2 is 4, 1, 5. Yep, there's the increase by 2. Negative 1 to the 3rd power, alternating signs, back to a negative 1, add 2 to the denominator, alternate the top, add 2 in the bottom, alternate the 1, add 2 to the bottom, and there's my pattern. And there's my sequence. So a lot of sequences you will discover there's a pattern in the numbers, and once you find it, you really don't have to keep evaluating. You can just use the pattern to find the numbers. All right, so the next thing we want to do is work backwards. What if we're given the sequence and we have to come up with the function? So if we want to work this out by hand, take 1357 and understand that this is when n equals 1, n equals 2, n equals 3, n equals 4. So I'm going to make a t-chart. So my n, which is my input, like your x, is 1, 2, 3, 4. A sub n is like your y coordinate, 1, 3, 5, 7. And I'm going to start to do the difference test. So between 1 and 3, I increase by 2. 3 to 5, I increase by 2. 5 to 7, I increase by 2. That's my slope if I'm on the first level difference test. So what I'm going to do is I'm going to make a third column. A sub n is now equal to 2n. So 2 times 1 is 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8. All right, that's not my numbers, 1, 3, 5, 7. So I asked myself, what do I need to do to the 2 to make it a 1? The 4 to make it a 3, the 6 to make it a 5, the 8 to make it a 7. Oh, I need to subtract 1. If I subtract 1 to all those numbers, there's my sequence 1, 3, 5, 7. There's my sequence function. We're done. All right, next example, we have 2, negative 5, 10, negative 17. The first thing that jumps out at me is my signs are alternating. So I have to have a negative 1 to a power. Well, our other example was n, but that would start out as an odd and make your first term negative. So to make the first term positive, and n is going to be a 1, we're going to go 1 minus 1, which is 0. Negative 1 to the 0 power is a positive 1. Or you could have n plus 1. When n is 1, plus 1 is 2, that will make it squared. Negative 1 squared is a positive 1. Either one is fine. N minus 1 is the most popular choice. So since this will take care of our alternating signs, go put it in your answer. Now make your t-chart. N equals 1, 2, 3, 4 again. A sub n is 2, 5, 10, 17. So I start doing my difference test. 2 to 5, positive 3. 5 to 10, 5. 10 to 17, added 7. This is not linear. These are not the same. So you do the difference test again. 2, 2. Difference test number 2 is second level, which means it's a quadratic function. So I make my third column n squared. Square my 1, 1. Square my 2, 4. 3 squared 9, 4 squared 16. Again, ask ourselves, what do we need to do to the 1 to get to a 2? 4 to get to a 5. 9 to get to a 10. 16 to get to the 17. Oh, we just need to add 1. So add 1 to all those numbers. 1 plus 1, 2. 4 plus 1, 5. 9 plus 1, 10. 16 plus 1, 17. So we take this n squared plus 1, which is a binomial, and multiply it to our negative 1 to the n minus 1 power. Make sure you put parentheses around it, otherwise your sign gets multiplied just to the n squared, not the whole thing.